Hello everyone, my name is True and my team member is Maria, Matthew, and Abra. I will present in the introduction to our project, the Bedside Weather Station. Next slide, please. Maria and say Abra are assigned for coding. Matthew assigned for product selection and implementation, and me for system design. Next, please. Project description. The Bedside Weather Display Station can minimize time spent in the morning, like checking your phone for the weather. Our projects are proven less time spent on your phone in the morning. In the proposal design, solve the problem by using a Node MCU Wi-Fi module to capture the information from the weather and transmit to 16:2 LCD display. The LCD will display like temperature, humidity, and precipitation. Now I'm gonna turn over to Matthew to continue our presentation.
Hi guys, I'm Matthew, and the parts used for this project included the ESP8266 Node MCU Wi-Fi module. There were different variations of this module, but ideally we opted for the one that included the micro USB. The HPC Curiosity board housed the PIC18F45K50 microcontroller, both made by microchip, and together allows users to program the microcontroller through the board. The Curiosity board has many peripheral functions, however, they were not utilized for this design as the microcontroller is meant to act independently. The board is only used to upload the code to the chip for this project. We also invested in the I2C 16-column by 2-row LCD backlit display. This was the main display for the device that users would see. Various jumper cables and 2 USB cables were needed for the HPC board and the Wi-Fi module for uploading code. The diagram on this slide shows how some of the previously mentioned components are connected to each other. The Wi-Fi module at the bottom right first acquires data from the online website, processes it, and transmit the information via the RX and TX pins to communicate through the UART communication protocol to the PIC18 controller. The PIC microcontroller processes the information received by the Wi-Fi module and displays it to the LCD display module through the I2C communication protocol. Compared to other projects, the wiring of this project is shown to be simple, and this is as a result of the UART and I2C communication protocols benefiting the workflow.
Hi guys, my name is Maria, and I'm going to go ahead and explain the block diagram for the weather station system that we designed. So our overall outcome is to display the weather on the LCD display and make sure that it's working properly. But we're not just talking about the regular temperature, we're talking about, is it cloudy, is it rainy, humidity, and we started that by connecting the PIC microcontroller to the Node MCU module, and this is by connecting the TX and the RX to each component and reversing that to the other component. And the other thing that we went ahead and we did was connect the PIC microcontroller to the LCD, and we used it by using the port B on our microcontroller. And moving over to the software of the device, we went ahead and we needed to get website credentials, and this was used by using the website openweathermap.org, where the API was given to provide the credentials, as well as this is the provided example of using the advanced user interface. And we also went ahead and we got some code provided to us from Pallavi, some example code, and we reconfigured it and reformatted it so that it could go ahead and work for our device. And this is by using the MPLAB and the Arduino IDE. Once everything was all set up and done, our feedback was given by the successful completion of the I2C LCD display working properly, as well as the Arduino IDE provides a serial monitor that we can go ahead and monitor how this device is working. And this basically just goes back to how the weather gets displayed in the overall system. And then in the next slide, we can go ahead and see the wiring diagram. And this is before we connected the USB ports to the computer. As you can see, the LCD is connected to the PIC microcontroller on the Curiosity board, and the receiver and transmitter terminals are switched from the RX of the microcontroller to the TX of the Node MCU, and as well as the RX of the Node MCU to the TX of the microcontroller. And I'm going to go ahead and leave you guys with Abrar, who's going to explain the code.
Hi everyone, I'm Abrar, and I'm going to be talking about the coding for the Node MCU as well as the PIC microcontroller. So at first we have the Node MCU coding, which we did in the Arduino IDE. So at first what we do is we initialize if you look at the top left corner, we initialize the Wi-Fi module by setting the SSID of the Wi-Fi network we're going to connect to, as well as the password, the API key, and the CTID. And after that, if you look at kind of in the middle, we have the setup, the void setup function, where we set a baud rate of 9600 for the Wi-Fi communication. And then the Wi-Fi module connects to the internet. And after that, it sends a specific string called connect now to the PIC microcontroller, and waits for a specific string back from the PIC microcontroller so that it configures the communication between two devices. And after that, in the right-hand side, it's just simple calling of functions to display certain strings in the LCD module, which it sends it by the serial communication protocol, which is the serial.println. And in the next slide, we'll look at how these specific strings are mapped out to like specific instructions that translate to the LCD. Next slide, please. So at first, we can see that there are a few header files that we use here, including the LCD header file, which is basically the reconfigured code that Pallavi provided us for the I2C LCD display. And after that, we can see like these functions, and two of these main functions are very important because the receive string function receives the serial communication from the Node MCU, and the UART send character function basically sends the serial information to the back to the Node MCU. And then in the main function, the void main function, we just initialize the registers of the TXSTA and the RCSTA for the UART communication. And then we initialize the LCD as well. And on the top right hand side, we can see that what it's doing is that it's kind of polling for a received signal from the Node MCU, and then unless it receives that signal, it does not continue further. And after it receives that signal, it sends a specific string back to kind of make sure that two devices are in communication. And then when we go to the infinite loop, we can see that it's continuously receiving information from the Node MCU, and it's kind of mapping a specific string, such as the clear it string, to the clearing to the LCD clearing function that we have for the LCD display. So it does that for a few commands to the LCD, and after that, which is the else command, we basically display whatever data we get from the internet, from the HDMI to the LCD display. Thank you.